Okay, so far so good. But what about regression problems? So till now we talked about classification problems. Okay, and we had the accuracy in our toolbox, and we learned about true positive rate and true negative rate. But what about regression problems? So for regression problems, we had mean absolute error. Also, we have the root mean square error. We want to introduce you to R squared. Okay, R2 or R squared. It's technically R squared. And this is something that we want to learn. So we have learned all these stuff. R squared is a performance metric for regression problems, problems in which the target variable is numerical. R squared or R2 measures the improvement or progress of our model from the naive model. So we introduce the baseline or naive or the null model. And this model has a performance and I said that we want to outperform it. So it's very rational to design a metric to show that how much we have outperformed this unsophisticated simple model, how much we have progressed from this baseline model. And this is exactly what R squared or R2 does. Its definition is quite simple. Okay, so the amount of improvement from the baseline performance over the baseline performance. And how we calculate the improvement? Well, the improvement is basically nothing but the model performance minus the baseline performance over the baseline. The improvement is nothing but the difference between the model performance and the baseline performance. It is like the baseline performance minus the model performance. So this is the improvement over baseline performance. Okay, since the baseline performance, if you consider it as an error term, the model would be better in general from the baseline, then the nominator would be a positive value. The baseline, also the performance, is a positive value. So in general, we would have a positive value. Okay. So let's talk a little bit more about why we need this R squared once again.